The problem name is minimum time to collect all apples in a tree. So given an undirected tree consisting of n vertices numbered from 0 to n minus 1, which has some apples in their vertices, you spend 1 second to walk over one edge of the tree. Return minimum time in seconds you have to spend to collect all apples in the tree, starting at vertex 0 and coming back at to the vertex. Means if you are starting, you have to start from 0 and you have to come to 0 only. You are starting from 0, you are like you are at 0. You have gone to 1, you have gone to 4. You have collected this apple, then you have to return 1, you have to return to 1 and you have to return to 0. You have collected, then you have to return your at your position coming, at your position back. So you have given this array of edges where this edges are undirected, which are not directed, and edges are from 0 to the vertices are from 0 to n minus 1. And if we are going from 0 to 1 at if we are moving one edge, then we are spending 1 second. So we have to return the answer in seconds. Minimum time in seconds to collect all the apples. Here apples are 2, 4 and 5. Apples are at 4, 5 and 2. So we have to collect all the apples and we have to return to 0 and we have to return the answer as minimum time we have spent. So how we can do this? We have given this edges. We can make the adjacent tree. As you know, if you don't know, you can just go through this. Like 0 is connected to 1 and 0 is connected to 2, 1 is connected to 4, 1 is connected to 5, 2 is connected to 3 and 2 is connected to 6. We can make this adjacent tree and n is 7. The nodes value is from 0 to n minus 1 means 0 to 6. We have has apple. Has apple we have given one has apple array. This question is the edge of the undirected tree are given in the array edges, where edges of I is a of I and b of I means that exist an edge connected the vertices a of I and b of I. Additionally, there is one Boolean array has apple, where has apple of I is true means vertices of I has an apple. Means if has apple of 2 is true means 2 is having an apple. So we have to collect it. We have to collect it. So how we can solve? The idea is I will solve this by DFS. I will go from 0. I will go from 0. I will say I will first I will check if 0 is having apple or not. I will take one integer temp in which I will store 0. Then if it is not having apple, okay, go to 1. Go to its adjacent. 0's adjacent are 1 and 2. Am I right? And 1's adjacent are 4 and 5. 4's adjacent is not 0, it's null. 4 is not having any adjacent, 5 is not having any adjacent. Okay, so I'm starting from 0. I will go to 1. At every index, if I'm going to 1, okay, if it is having an apple, then I have to return to 0. So how much time it is taking? For every node, it will take 2 seconds. It will take 2 seconds because I have to go to 1 and I have to return to 0. So at every index, I have to spend 2 seconds. So I will take this 2 also. So I'm going to 1. Is it having apple? No, it is not having. Okay. Here I have taken one count. Count is 2. Error and our answer. Answer is also 2. Answer is also 2. No, I will at every index I will add this 2. I will add this 2. It is not having apple. Okay. If it is not having apple, I will return some number. You just wait. If it is not having an apple, I can return 0 and I can return the answer. Okay. So now first adjacent are 4 and 5. I will go to 4. I am going. Okay. Count is 2 only. But answer is 2 plus 2. Count plus previous count. From previously, from which index I am coming, that answer I have to add, no? So 2 plus 2. Count is 2 only. So answer is 4 here. Is it having apple? Yes, it is having apple. So if it is having apple, I will return this answer. I will return this answer. Now, first adjacent is 5 also. Here, answer is 2. Count is 2. I will say answer is 2 plus 2. Answer is 2 plus 2. Count is 2 only. It is having apple. Yes, it is having. Is it having apple? Yes, it is having apple. So I will say return this answer. Return this answer. Okay, I will add this. Now, 0 if is 1 is having apple. No, it is not having apple. Now, you just add both of them. 4 plus 4 is 8. 8 and return 0 from here. 8 plus 0 means return 0 from here and add 8. Return totally 8 from here. Why 8? Why 8? 2 from here. 2 from here. Sorry, it's not 8. It is not 8. I have gone to here. Okay. It is taking 2 plus 2, 4. But from here, I am going to here. And this is also taking 2 seconds. 2 seconds plus 2 seconds. I have add these 2 seconds to 4. 4 here. Sorry, 4 here. Because it is returning 2. It is returning 2. And 2 plus 2 is hearing. Here I am adding to 4. Now it is returning 0 and it is having count 2. This is having count 2 and it is returning 0. Then I will return 2 plus 4. What I have to do, I have to just return, means if, just wait for a second. So what I have to do, if any vertex is having apple, I will say return your count. If this edge this vertex is having apple, I will say return your count. Okay, return your count and add them together. Add them together. Now I will take one and I will take one temp. I will say I am having apple. I'm having apple from down vertices. I'm having apple from previous vertices. So you have to add this path also. So means I have to give the information that path I have to include or not. If I am having any apple here, any apple in these leaf nodes, then I have to add all the path to node, all the path to node, because I have to return. I have to return. You're getting my point. If I have found apple here, then this path I am taking. This path also I have to take. This one is having apple or not. This is not this is not our point. This one is having apple. This one is having apple or it is not having apple. I have to add this path because I have to return to node. So if any node is having apple, I am coming from, then I have to add the path to every path which is going to 0. Okay. So here 4 is having apple. So its path length is 2. Its path length is 2. So I have to add them. It is 4. Here it is 4. Its path length also 2. So I have to add this and I have to give it to 6. Now I am going to 2. Is it having apple? Yes. So I will add this 2 and I will say I will add I will okay, I have to just now I'm going, if it is having apple, I will say return 2. Return 2. Now 2's adjacent is 3. Is it having apple? No, it is not having. Then its path length I will not consider. I will say return 0 only. return 0 and don't add anything. Also from 6, I will say return 0, don't add anything. So 0, I'm returning 0 here, and 2 is returning 2. Why? It is having apple, so it will return its path length. 0 plus 2, it will return to 0. So 6 plus 2 is 8. 6 plus 2 is 8. To collect all the apples, I have to spend 8 seconds. How? This 1, 2, 3, 4, 5, 6, 7, 8. The code is very easy. Maybe approach which is not totally clear to you. You can watch the video again or you can go through the code. You will understand. First, I am just making the adjacent tree. Adjacent tree is 0 is connecting to 0 and 0 is connecting to 2. So this I am making. Also, I am taking a visited array which is n plus 1. I will take care of the nodes which I have visited. I will not visit them again. So I am saying visited of node is 1, visited node of true, visited of node is true. I have visited this node. Okay. I am taking an answer. Answer is 0. I am going to every adjacent of this node. Okay. The adjacent is x. If x is not visited, I will I will add the I will add this DFS answer, the return, which this vertices is this vertex will return the answer. I will add this with this vertices is return the which number I will store it in the answer. I will add them together. Now if any node is not having apple and its answer also 0, means this node this this means this node is not having any apple, but the answer is here is 4, as I have stored. Here it is not having any apple, but the answer is here. Answer is 4 because these vertices having apple, so I have returned the answer. So here answer is 4. So this will this will give me the information if answer also 0 and any this vertex is also not having apple, then I have to return 0. But at but and in another cases means if any vertex is having apple or this vertices is not having apple but its answer is not 0, means this vertices is not having apple, having any apple but its answer is not 0, then then also I have to return answer plus count, means then also I have to take this path count. Then also I have to take this path count. So I have to return answer plus this answer plus this path count. Count is 2. This I have taken this one variable count. In count I have taken this 2, this 0. First I have taken to 0 because at the root node I don't have to spend any second. It is 0. But at every in every call I am giving 2. I am giving 2 because path length is 2, coming and going back, coming and going back. So if any node is not having apple and its answer is also 0, then I have to return 0. But any node is having apple or any node is not having apple but its answer is not 0, then also I have to take care of this path because I have to return to 0. I have to return to root node. So the approach is clear to you. You can submit the code. It has submitted successfully. Thank you.